Hi, welcome back to class. In today's video, we will be looking at how to balance chemical equation. What is a chemical equation? A chemical equation is a symbolic representation of a chemical reaction. So in chemistry, how we represent our chemical reactions is by using chemical equation. And with a chemical equation, you can get the following information. The first one is the reactant, which is always at the left hand side of the chemical equation. The second one is the product. This is always at the right hand side. Another thing you can tell is the relative amount of the substances. So I'm going to shorten my substance. Alright. So the first one, you can also sometimes tell the physical state and the reaction condition. I'm going to write my reaction like this. Reaction conditions. Okay. So basically, a chemical equation should be able to tell you these four things, or 3 out of 4. So now, basically, reactants gives you product. So this is how we represent it. That is why I said the reactant is always at the left hand side of the equation, and the product is always at the right hand side of the equation. So the reactant, this arrow means produce, okay? Or you can call it yield, or you can say the reactant reacts to give you the product. So, all right, so let's look at an example. So let's consider the formation of water. We have you. All right, so this is the chemical equation for the formation of water. It's saying now we can tell our reactant, which is reactant. I'm going to say R is what? Hydrogen molecule and oxygen molecule. What is our product? Our product is water, which is H2O, right? And we can also tell the amount. We can see that 2 moles of hydrogen molecule is reacting with 1 mole. It's just invisible, okay? One is invisible. So 1 mole of oxygen molecule to give us 2 moles of water. So you might be wondering, how do we get this number? How do we come about this coefficients? Because they are called coefficients, okay? This number, so the numbers here are called coefficients, and I know you know the meaning of these numbers. It's just the number of atoms and their subscripts, okay? So how do we go about knowing what the right coefficients for a particular chemical equation will be? Then that is when we talk about balancing chemical equation. So that is what we'll be doing now, all right? Why do we need to balance chemical equation? Remember that there is a law in chemistry, which is the law of the conservation of matter, which says matter can neither be created nor destroyed. So, if matter can neither be created nor destroyed, definitely when you are writing a chemical equation, you have to make sure that the number of atoms you have in the left hand side is the same as the number of atoms you have in the right hand side for a particular element. Okay, so let's consider um water that we used as example earlier. So we have H2O. Imagine we don't know the coefficient that was there before. So let's go. Now, how do we determine the coefficients? Or let's even check it. Do we need any coefficients aside the one that is there? Or we need to do something? So the first way to do it is to count the number of atoms in each of the sides. So you will be able to know what you want to do exactly. So you can have a mini table. Okay, so for the first step, let's count it. Now we have, so you write the elements, just a mini table, okay? So you have elements, you have hydrogen, you have oxygen. Now you are going to write reactants so that you know the number of products, okay? So let's count it together. In the left hand side, which is the reactant side, so we have two atoms of hydrogen. You can see two atoms of hydrogen. So you are going to write two here. Let's look at the product side. We have two atoms of hydrogen also. So we are going to write two there. Okay. Now let's look at oxygen. We have two atoms of oxygen here. And in the product side, we have only one atom of oxygen. So we're going to write one. So looking at this, for hydrogen, we have two atoms at the reactant side and two atoms at the product side. But for oxygen, we just have two and one. So what do? A simple way is to look at the LCM. What's the LCM for two and one? It is two. So I can make, since this is already two, I should make this two. Okay, so that means I'm going to um multiply the coefficient that is here before by two. All right, so let's do it. Step one. So we have H2 plus O2 to give you 2O2. Anytime you change the coefficients, always recount the atoms because it might change. Sometimes it will not change, but most times it changes. So it tells you what you need have to do next exactly. So let's see if this changed or not. So for hydrogen, on the left hand side we have two, so we're going to write two. For for the right hand side we have two times two because this two is for the two elements. The coefficient is always for the whole formula, not just one atom, okay, or not just one element. It's for the whole chemical formula. I mean, so now we have four. For the oxygen, let's check. We have two here, all right, and since we said the two is for the two elements, so it's going to be two atoms of hydrogen, of oxygen. I mean, so now oxygen check. How can we fix hydrogen? Hydrogen was fixed before, but now it's it's um not complete, so we have to fix it. All right. So once again, we are going to look at the LCM of two and four, which is what? It's four. And how can we make this side four? Since one of it is four already, so we can do that by multiplying this side by two. Definitely, we are going to put two before here. So step two, put two before this. So we have two to give you this. All right. So let's check if we have balanced the equation or we still need to do additional steps. So we have 2 times 2, 4. For the left hand side, we have 4 hydrogen. And for the right hand side, we also have 4. 2 times 2, 4. Okay, good. For the oxygen, we have 2 on the left hand side. Good. And for the right hand side, we also have 2. Very good. So since they are all equal, we have balanced our equation. So our balanced equation is 2 moles of hydrogen molecules reacting with 1 mole of oxygen molecule to give us 2 molecules of water. Okay, so this is balanced. So let's look at another example. Okay, so this is another example. This is the reaction between iron and oxygen to give us iron oxide. Alright, so how do we know if this is balanced? First, you have to count the number of atoms. Is the number of atoms present at the reactant side the same as the number of atoms present at the product side? So let's find out. For iron, so we have to write the elements. So we have two elements in this um, question, and that is iron and oxygen. So iron, we have one at the reactant side, while on the product side we have two. For the oxygen, we have two on the reactant side, while on the product side we have three. Interesting. So which one are we to do first? Okay, so we are going to start with the oxygen. Well, because these two numbers look weird, and this is where the principle of the LCM, lowest common multiple, works. So what is the lowest common multiple of 2 and 3? It is 6. So we have to make this side 6 and also this side 6, but we have to do it one after the other. We don't rush. Okay, you take a step at a time. So let's go. First, what we are going to do, let's make this side 6. So how do we make this side 6? The oxygen that is here 6. We have to put 2 here. Remember that we don't change the subscript. The only thing that we can change is the coefficient, okay? We can't change the subscript because by changing the subscript, we are going against the law of the conservation of mass, okay? So now we are going to put 2 before this compound. Now step 1. So putting 2 before, we have, so let's find out if we have gotten the answer. So let's count the atoms on both sides. Um for the iron, we still have 1. For the product side, we have 4 now because this is 2 times 2. Okay. Now for the oxygen, we have 2. We still have 2, but on this side we have 6. So we are going to make this side 6. We already know what we want to do before, but we have to do it step by step. So step 3, we just have to put 3 before O2. Okay, so we have Fe plus 3 O2 give me 2 Fe. So now we still have 1, and we still have 4 here. We have 6 now, and we have 6 now. So for oxygen, it is checked. Now, how can we make this balance? We have 4 of iron on the product side. So on this side, we are going to put 4 there. So step 4, step, oh, sorry, step 3 is going to be put um 4 before um, so we have 4 Fe plus 3O2 give you 2 Fe2O3. So let's check if this is balanced. Iron, we have 4 on the reactant side. On the product side, we have what? 4 again. Okay, good. So for oxygen, we have 6. And for the product side, we also have 6. So that means we have balanced the chemical equation since both sides are equal. So let's try out another example. Alright, I want you to pause this video and try if you would be able to solve this question. Okay, let me show you a quick way to solve this particular question. When we have polyatomic ions like SO4 2 minus, CO3 2 minus, PO4 3 minus, okay, and OH minus in ionic compounds that are dissociated, okay. Okay, so you can treat them as a single unit if they are not changed, like the form is not changed when they were in the reactant side. By the time they got to the product side, they still remain the way it is. I mean, for instance, let's look at H2SO4 plus um let's say NOH, okay. So we have Na2SO4 to give you H2O. You can see SO4 here is still the same SO4 there, okay. It's still taking the same form, okay, it's still taking the same form. Then OH here is still the same because this can be written as H plus and OH minus. And this one too can be written as Na plus and OH minus. So to save yourself time, you can treat all these ones as single entity. Note OH when it is in an ionic compound, not a covalent compound. Okay, so um that is the faster way to do it instead of counting the atoms one by one. But even if you do that, you still get the answer. What are the elements we have? Let's write it. Element. We have Na, we have HOCl. Okay, we have that. For the product reactant type, I have one, product one, two, because this is one hydrogen, this is another hydrogen, two. Then for the product, I also have two. For the oxygen, I have one, and I also have one. For the chlorine, I have one and one. So all this, so this equation is already balanced. Now, OH is a polyatomic ion in this particular equation. So we can say that we have sodium, we have OH, so we are treating it as a single entity. We have hydrogen, which is the separate entity here, and we have chlorine. So let's see if this method will work. Alright, so sodium here and sodium here. Sodium is what? 1 and 1. Remember that this is like H plus and OH minus. Okay, so that is the way we will see this H2O. So OH here we have 1, OH here we have 1, hydrogen here we have 1, hydrogen here we have 1, chlorine here we have 1, chlorine here we have 1. So we can look at it that all these are the same. So definitely this equation is balanced. Okay, we don't need to change the coefficient. Now let's look at another example. We have C3H8 reacting with oxygen to give us carbon dioxide and water. So first thing first is to do what? Yes, to write the elements and also to count the number of atoms at both sides to see what exactly we want to do. All right. Yes. So let's look at it. So we have carbon, we have hydrogen, and we have oxygen. Okay. Now let's look at it. For the left hand side, we have 3 for carbon, and right hand side 1. For hydrogen, we have 8. Left hand side, we have 2. For oxygen, we have 2. And for the right hand side, we have 2 here and 1 here. So that's 3. Okay. For this example, I'm not going to start with oxygen. I'm going to be doing oxygen last because oxygen is appearing in 2 places at the reactant side. So at the product side, I mean. So when we have a particular element reoccurring in 2 different products, then or is even occurring in 2 different reactants. So we try to do them last. Okay, so let's focus on this the let's start with carbon first. So for carbon, we have 3 and 1. So what's the LCM of 3 and 1? Very good, it's 3. So you have to, make this place 3 since this is already 3. Step 1, we are going to put 3 before CO2, okay? So that way we have CH3H giving reacting with O2 giving you 3CO2 plus H2O. Let's check if what we have written here has solved the problem. Now we have 3 for carbon, 3 for carbon, very good. For oxygen, for hydrogen, we have 8, we have 2, we still have 2. For oxygen, we have 2 here, and let's look at it now. We have 3 times 2, which is 6. Then we have um 1 here. So 6 plus 1 is 7. So now we have 7. Okay. Now what are we going to do? Let's look at hydrogen next. Okay. Once again, we're doing oxygen last because it's occurring in more than one product. Okay. So hydrogen, we have 8 and 2. What is the LCM of 8 and 2? We have 8. So since this side is already 8, we're going to make this side 8. Then they can be equal. What will I multiply by 2 to give me 8? 4. So I'm going to put 4 at before H2O so that I can have 4 times 2 to give me 8. So step 2, so let's check if what we have done is actually correct, or let's check if it has solved the problem. Now for the carbon, reactant 3, product 3. For the hydrogen, we have 8 on the reactant side. Let's check on the product side. We have 4 times 2, which is 8. Okay. For oxygen, we still have 2 on the reactant side, and on the product side, we have what? 3 times 2, 6, and we also have 4 times 1, which is 4. Now, 6 plus 4 is 10. So we have 10. Okay, now we can, since we have balanced carbon, we have balanced hydrogen, we are left with oxygen. So we have 2 and 10. What is the LCM of 2 and 10? It is 10. Very good. And this side is already 10. I need to make this side also 10. So what will I multiply by 2 to give me 10? 5. Good. So that means we are going to put 5 in front of the oxygen molecule. Let's check. Carbon 3, other side 3. Hydrogen is other side 8. Oxygen 10. 5 times 2 is 10. Then we have 3 times 2 is 6. 4 times 1 4. Adding it together 10. So we have everything balanced. So this equation is balanced. So as a recap of what we have learned, when you're about to balance a chemical equation, first thing is to know the element you are working with. Count the atoms of each of the elements at the reactant side and the product side. Look at it. Are they balanced? If they are not balanced, then you have work to do. Remember that you don't change the subscript, but you can change the coefficients. Okay, you don't touch the subscript because you don't want to be making a new product. Okay, so with this, doing it, and remember you have to do one element at a time. You don't do 2 elements together. Do it step by step. That is how you get it clear. And with that process, you'll be able to get your balanced chemical equation. You'll be seeing some practice questions. I want you to drop your answers in the comment section. And also, if you have any question, put it in the comment section. I'll be there to attend to them, and I will guide you through the process. Alright, if you have enjoyed this video, please do well to share to your friends and everyone that you think might be struggling with balancing chemical equations. Do not forget to like this video, to share to your friends, to comment, and also to subscribe to my channel. I'll see you in my next videos. Bye!